In this exercise, we're going to look at measures of variation. Measures of variations are about how far each data point is relative to the mean of the data. So variance takes the deviation, squares the deviation, and finds the average of the squared deviation from the mean. And there are two different formulas, one for sample, one for population. So we'll consider our data as a sample. So variance function is VAR, and dot P is for population, and dot S is for sample. So we're going to use VAR dot S, and then you do MPG. That will give us the variance, which is this average of the square deviation of each data point from the mean. Square root of that is the standard deviation, so we can use the square root function to find the standard deviation, or you can use the standard deviation function. Again, it is stdev dot p for population and dot s for sample. So MPG gives us a standard deviation of MPG. Range is the difference between the maximum value and the minimum value, and there is no Excel function for that, so we have to set this up as a formula. You take the maximum value, we've already computed that here, minus the minimum value, so that will give us the range of the data. Now interquartile range is the difference between the third quartile and the first quartile. So that is the mid 50% of the data. So we have already computed the third and the first quartile. So third quartile minus the first quartile. So that's our interquartile range. Now coefficient of variation is a unitless or unit free measure of variation. So that is standard deviation divided by the mean is the coefficient of variation. So we take the standard deviation, divide by the mean, gives us the coefficient of variation, and this is a way to compare different variables, the amount of variability in different variables when the unit of measure is different for the different variables. Skewness, kurtosis, these are distribution measures. The level of skewness in the data, is it equally distributed like in the normal distribution, or does the data have a positive skew or a negative skew? Positive skew is when the data is skewed to the right, then negative skew would be when the data is skewed to the left. So this one has a slight positive skew because it has a positive skewness. Now, kurtosis, which is KURT, measures how peaked or flat the distribution is. 0 being the normal, if it is like in the normal distribution. If you have positive kurtosis, then it is more peaked than normal distribution. If it is negative, then it is more flat compared to normal distribution. Now, this is negative. In our case, we have a negative value, so it is the distribution is flatter compared to normal distribution. Z-score is a standardized deviation, how many standard deviation away from the mean the particular data point is. So this is for, you can compute the Z-score for each and every data. And suppose we want the Z-score for a data value equal to 25 MPG, then we go 25 minus the mean. So mean is the average that's at the top, we have calculated that. So this is the amount of deviation in absolute sense. When we divide that by the standard deviation, which is here, then we convert the amount of deviation into the number of standard deviations away from the mean. And this is a very important measure to standardize the deviations of all the data points.